Everyone and welcome back to SK1KS, and today what we are going to talk about is quite something really important when you are trying to learn physics, and something really important when I say that कि जब भी हम लोग physics सीखने की कोशिश करते हैं we often come across this mathematics that we try to that we have to learn, that we have to understand in order to understand all the physical principles that you'll be studying. तो in the meanwhile अगर आप देखो so you can all often see many kind of science videos on YouTube or any other such kind of website that are trying to explain science or physics. Particularly most of them are based on quantum mechanics or relativity and these modern ideas of physics, तो जो कि बिना मैथमेटिक्स के आपको वो उन चीज़ों को एक्सप्लेन करती हैं. दे विल एक्सप्लेन यू क्वांटम मैकेनिक्स विदाउट द मैथमेटिक्स, एंड ऑब्वियसली नो ऑफेंस टू एनीवन इन दिस वीडियो. So I do not really intend any offense. लेकिन यहाँ पे is it really possible to understand these concepts without the necessary mathematics? And that is a question that must be answered. The thing is कि when you try to learn physics, the question is first of all, the first question that you must ask yourself, why learn mathematics? So the question is why learn mathematics? But before that, we might as well question something else. Why learn physics in the first place? Well, learn physics क्योंकि physics explains reality, of course. Physics explains nature. If you want to know the truth, if you want to know reality, if you want to know the way this world works, you need to know physics. That's why you need to learn physics. That's why physics was developed in the first place. You see, natural philosophy is the root from which physics arrives in its current form. Arises more accurately. तो यहाँ पे न्यूटन ने अपनी philosophy या naturalist principia mathematica with English translation as natural principles of mathematical principles of natural philosophy publish किया था, and there he showed कि natural philosophy को mathematics के साथ quantitatively समझा जा सकता है, and these laws of the earth are the same as the laws of the heaven. तो उसके पहले जो हमारी फिलॉसफी थी एट द टाइम्स ऑफ एरिस्टोटल, तो एरिस्टोटल का बेसिकली उसी फिलॉसफी के फील्ड में एंड इवन ऑल दीज काइंड ऑफ क्वेश्चंस दैट वी हैड रिगार्डिंग आवर रियलिटी, रिगार्डिंग आवर एग्जिस्टेंस और रिगार्डिंग दिस प्लेस वी एग्जिस्ट इन, दोज वर मेनली आंसर्ड ऑन द बेसिस ऑफ एरिस्टोटल्स फिलॉसफी. अब एरिस्टोटल की फिलॉसफी काफ़ी क्वालिटेटिव थी ऑब्वियसली, एंड यू सी there were lots of fallacies in Aristotle's philosophy. तो वहाँ पे Galileo comes along the way and he shows that these are some fallacies that need to be corrected and that may be modified in such manner, and this is the actually true thing that is happening. This is what Aristotle's philosophy tells us, and that is clearly wrong. But you see, people did not really believe Galileo at that time, and then Newton comes along the way and Newton tells us the very same thing. He expands on Galileo's ideas. उन्होंने Galileo के idea पे को expand किया, and he developed his own mechanics. He developed his own philosophy, Newtonian philosophy, and this natural philosophy that Newton was trying to study, he did it on the basis of mathematics. So Newton comes along the way and he tells us कि इस natural philosophy को, what is natural philosophy? Well, it is the philosophy concerning the behavior of bodies. It is the philosophy concerning the behavior of bodies of earth and the heavens, because Newton told us that the laws governing the earth are the same as the laws governing the heavens. And that was quite a big achievement, quite an intellectual achievement in that time, to think कि हमारा जो जैसे एक पेड़ से एक एप्पल गिरता है तो वहां पे वो जो लॉज उस एप्पल के मोशन को डिस्क्राइब करें, दीज आर द सेम लॉज जो कि उस मून के मोशन को भी डिस्क्राइब करें अराउंड द अर्थ, और द अर्थ्स मोशन अराउंड द सन. देन न्यूटन used this idea of natural philosophy, developed his own natural philosophy, the philosophy that helps you understand the behavior of these bodies using mathematical principles, and that's why it's called mathematical principles of natural philosophy, Newton's masterpiece. एंड वहां पे उन्होंने दिखाया कि कैसे यूजिंग हिज न्यू ब्रांच ऑफ मैथमेटिक्स दैट ही इन्वेंटेड, कैलकुलस. ऑब्वियसली लाइबनिज ने भी कैलकुलस इन्वेंट किया, तो ऑफन यहाँ पे बहुत कंफ्यूजन होती है, न्यूटन ने इसे इन्वेंट किया या फिर लाइबनिज ने किया. वेल, उन्होंने एक दूसरे की हेल्प नहीं ली थी. सो इफ यू थिंक ऑफ सम वे कि दोनों ने साथ में मिलकर किया होगा, नो, इट डोंट हैपन दैट वे. न्यूटन एंड लाइबनिज इन्वेंटेड कैलकुलस इंडिपेंडेंटली। उन लोगों ने कैलकुलस को इंडिपेंडेंटली इन्वेंट किया था। न्यूटन ने अपनी ओन कैलकुलस इन्वेंट की, ऑल्दो बोथ आर कैलकुलस ऑफ कोर्स। न्यूटन ने अपने नोटेशंस बनाए, लाइबनिज ने अपने नोटेशंस बनाए, and both concerned the new mathematics with rates of change of quantities, of course, because just algebra was not enough for them to solve their problems, and for Newton it was the falling apple and the falling moon problem. तो न्यूटन ने इन प्रॉब्लम्स, इन फिजिकल प्रॉब्लम्स को सॉल्व करने के लिए अपनी कैलकुलस इन्वेंट की, एंड ही शोड कि कैसे उनकी मैथमेटिक्स के अकॉर्डिंग आप नेचुरल फिलोसफी को अंडरस्टैंड कर सकते हो। एंड दैट वाज व्हेन वी स्टार्टेड अंडरस्टैंडिंग थिंग्स क्वांटिटेटिवली। नाउ द क्वेश्चन इज कि अगर हम लोग फिजिक्स को, ऑफ कोर्स दैट इज वेयर द आइडिया ऑफ फिजिक्स इटसेल्फ कम्स फ्रॉम, अगर हम लोग फिजिक्स को मैथमेटिक्स के बिना अंडरस्टैंड करने की कोशिश करें, so do we want to go back in the times of Aristotle? Do we want to go back to those fallacies of thoughts? That is the question, because unless you understand things quantitatively, you cannot exactly tell whether the things that you have studied qualitatively or that you have thought qualitatively are accurate or not. There is no such way to tell. Of course you may use logic, अगर ये लॉजिक के साथ कंसिस्टेंट है, because logic is of course the way of the world. Now logic and common sense, I would say, are two different things, because common sense is something that we identify and that we develop on based on the things that we see and how we perceive them. But on the quantum level or the very macroscopic level or at the levels where there are very high speeds, हम लोग common sense तो use नहीं कर सकते, because of course you see in those places हम लोगों ने उन चीज़ों को experience नहीं किया. But logic, well, logic still valid, and logic is clearly where mathematics comes from. So the very thing, the very statement that 1 plus 1 equals 2, अगर आप देखते हो, आपको कैसे पता चला कि 1 plus 1 2 के इक्वल होता है? Well, based on logic, that is how you know कि अगर मेरे पास एक एप्पल है और एक और एप्पल है, तो अब मेरे पास टोटल 2 एप्पल्स हैं. द क्वेश्चन इज कि क्या अगर इसी चीज को मैंने प्लैनेट्स तक एक्सटेंड करने की कोशिश किया, क्या यही लॉजिक काम करेगा? वेल, इट डज वर्क. इफ यू हैव one planet and another planet, you have a total of 2 planets. Does it work on a microscopic level? Well, you have an electron and you have another electron, now you have 2 electrons. It does work because it can be derived through steps of logic. In fact, Bertrand Russell ने अपनी Principia Mathematica, whose name is very similar to Newton's Principia, तो अपनी Principia of Mathematica में in fact proof दिया using his notations, very ancient notations indeed, that 1 plus 1 equals 2. Yes, there actually exists a proof of this thing that 1 plus 1 equals 2. तो यहाँ से हम लोग समझते हैं कि मैथमेटिक्स एक्चुअल में लॉजिक से डिराइव किया गया और एटलीस्ट डेवलप किया गया. वेल, फिलोसफी भी तो लॉजिक से डेवलप की गई है, नेचुरल फिलोसफी, एंड दैट इज व्हाई नेचुरल फिलोसफी एंड मैथमेटिक्स complement each other. That is one very important thing that you need to understand. They complement each other, and they complement each other very well, very properly indeed. And this is why understanding one of them helps you in understanding another. Now, one thing that you have to understand, ki natural philosophy. So here when I say natural philosophy, I actually mean physics, or mean at least in a theoretical sense physics. When done the very same thing mathematically, well, of course that's physics. So physics is not mathematics and mathematics is not physics, but they still complement each other very well. And why is that so? Because both are basically derived from facts and logic, and if not so from facts, because we don't know how things work on a quantum level or microscopic level unless we develop them. So the thing is, they both are derived from logic of human existence. Of course, we exist and we know that things happen logically, things happen rationally, and based on just the very same fact that you can explain things logically, we have developed physics and mathematics, or at least physical models, developed physical models, because physics is something that cannot be invented, or invented mathematical tools. Now that is what you need to understand, कि Newton used his mathematical principles, derived many mathematical principles, or invented calculus so that he can understand actually what is going on in this particular in the system of this world. Now there came along the way many other physicists, many other mathematicians developing their mathematical principles or their physical models, and karte karte we go to the time of relativity, where relativity was discovered by Albert Einstein, or the quantum mechanics in the 1920s and 30s, to the Heisenberg uncertainty principle in 1927. And आज के time में आए, so we see there are many of these physical models which explain physical reality pretty well. तो यहाँ पे हमारा एक पूरा modern physics अगर देखें, so it lies on two physical models, the general relativity and quantum mechanics. So often you will see science popularizers, of course, explain your general relativity and quantum mechanics, and they explain you in rather a quick and easy way, of course, without any mathematics at all. तो डज इट मीन कि जो हम लोग मैथमेटिक्स को यूज करने की कोशिश करें ऑल दिस टाइम फ्रॉम द टाइम ऑफ न्यूटन, फ्रॉम व्हेन न्यूटन पब्लिश हिज प्रिंसिपल, और फ्रॉम वेयर द अदर हिज पायनियर्स, हिज कंटेम्पररी साइंटिस्ट और फिलोसोफर्स और मैथमेटिशियंस अंडरस्टूड कि नेचुरल फिलोसफी को मैथमेटिक्स के साथ क्वांटिटेटिवली अंडरस्टैंड किया जा सकता है. सो हैज दिस ऑल टाइम बीन अ वेस्ट कि बिना मैथमेटिक्स के हम लोग इस चीज को अंडरस्टैंड कर सकते हैं? Well, the clear answer is no. That's a big no. You cannot understand these things without mathematics. So we must ask ourselves question that why can't we understand these things without mathematics? And the answer is mathematics is the language which helps you in communicating to nature. It is the language of nature. It is the language of physics. That's why it's called. H.C. Verma sir ने भी अपनी book Concepts of Physics में clearly लिखा है कि mathematics is the language of physics, and not only him, any physicist that you'll talk to or you'll read books of, they will clearly tell you mathematics is the language of physics. तो अगर आपको नेचर को अंडरस्टैंड करें, रियलिटी को अंडरस्टैंड करें, you need to understand mathematics, you need to understand mathematical principles, you need to know that 1 plus 1 equals 2, otherwise you cannot do it, you just can't. तो क्या रिलेटिविटी या क्वांटम मैकेनिक्स या फिर इन फिजिक्स कंसेप्ट्स को बिना मैथमेटिक्स के अंडरस्टैंड किया जा सकते हैं? विल यू गेट द जनरल आइडिया बिहाइंड देम, you may get the general idea behind the mathematics, but you don't understand those things without mathematics. So it's something like this, that regarding quantum mechanics, अगर मैंने quantum mechanics का एक example लिया, you'll often find yourself reading popular science books or watching popular science videos on YouTube, and you'll find yourself that the person explains quantum mechanics in such a way जिससे आप बिना mathematics के उसे understand कर सकते हो और without past background. So even here on this board only, I had previously explained quantum mechanics in my other video, and the thing was done pretty mathematically as far as we can see. And you see, you take an example of an electron. तो अगर मैंने एक इलेक्ट्रॉन को एक बॉक्स के अंदर रखा है, so what you'll find is कि ये इलेक्ट्रॉन वेव बिहेवियर को एग्जिबिट करता है. And unless you open the box, I cannot even really tell where the electron is to be found. जब तक मैंने बॉक्स को नहीं खोला, तब I cannot tell कि इलेक्ट्रॉन मुझे यहाँ पे मिलेगा या फिर यहाँ पे मिलेगा या यहाँ पे या यहाँ पे. So I can tell you this general idea behind the very same thing this way qualitatively without actually making you go through the entire mathematics. Now the question is, what's the proof? What's the proof कि ये इलेक्ट्रॉन मुझे यहाँ पे मिल सकता है, यहाँ पे एंड यहाँ पे एंड यहाँ पे भी मिल सकता है? Well, Born's statistical interpretation says so. Now, what is Born's statistical interpretation? Well, Born's statistical interpretation is that the probability of finding the particle between two positions A and B is the spatial integral from A to B of the absolute value of the wave function squared. That is Born's statistical interpretation. So here you tell the probability कि ये particle यहाँ से यहाँ तक होने इस range में है, तो इसकी probability क्या है? Now that is something very mathematical. Of course, here integration is involved between two spatial points. You square the absolute value of a quantity. What quantity? The wave function. Now what is the wave function? So you need to understand what is the wave function in order to truly understand the behavior of this electron in this box. What is the wave function? Well, wave function एक हमारा mathematically एक mathematical function होता है, an abstract mathematical function which is involved in the time dependent or the time independent. So let's take for instance time dependent Schrodinger equation, जिसे solve करने के बाद ही हमें कुछ specified potential energies या फिर boundary conditions के लिए ये wave function मिलता है. एंड जो कि हमारी प्रॉपर्टीज ऑफ द पार्टिकल और ऑफ द वेव, बिकॉज इट एग्जिबिट्स अ वेव पार्टिकल बिहेवियर, कंटेन करता है. सो यू हैव एक्सपेक्टेशन वैल्यूज ऑफ position or momentum or any other such thing that you could possibly calculate. So all this information is encoded right there in this mathematical function, the wave function. How do you find it? Well, you solve the Schrodinger equation for those conditions. So here to truly understand कि क्या सच में पार्टिकल ऐसा बिहेवियर एग्जिबिट करता है, so you need to understand Born's statistical interpretation. For that you need to understand wave function in the Schrodinger equation. So can you prove to me कि इलेक्ट्रॉन सच में ऐसे probabilistic behavior exhibit करते हैं? Well, I don't think one can unless one works through the mathematics. So you have to work through the mathematics to actually understand or to comprehend the idea that the electron exhibits probabilistic nature, that all the particles and all the waves have probabilistic behaviors to them. तो इन फैक्ट्स को तो बताया जा सकता है विदाउट एनी एक्सप्लिसिट यूज ऑफ मैथमेटिक्स इन देम. तो इन फैक्ट्स को बताया जा सकता है लेकिन उन्हें अंडरस्टैंड नहीं किया जा सकता या फिर उन्हें कॉम्प्रिहेंड नहीं किया जा सकता विदाउट द यूज ऑफ मैथमेटिक्स, because it is the way physics is written. It is just the way and you can't change anything about it. So to develop an idea or to develop an interest, at least we often find ourselves watching these kind of lectures and videos and reading these popular science books, which of course I have no offense towards, लेकिन इनसे फिजिक्स को अंडरस्टैंड नहीं किया जा सकता. So if you want to understand physics, I would say understand mathematics. You need to learn mathematics, or you'll think that you're actually able to comprehend this idea, and you'll fall under whatever nonsense or whatever trap that is being spread around all this time, and people who think that they are actually explaining quantum mechanics, not to mention anyone. So the thing is, unless you understand the mathematics, so it is something like this: you solve a particular case, a particular problem, and after you solve the problem, when you got a result, now you might question yourself कि ये मैंने मैथमेटिक्स मुझे ये बताती है कि मुझे ये रिजल्ट मिला है. सो मैथमेटिक्स टेल्स यू द रिजल्ट. नाउ यू नीड टू क्वेश्चन योरसेल्फ दैट व्हाई डिड आई गेट दिस रिजल्ट. that is the question you must ask. So for instance, let me take an example. I was reading Feynman lectures, which are of course considered the bibles of physics, and वहाँ पे you particularly find one very interesting point regarding the speed of sound, where Feynman tells us कि पहले न्यूटन ने speed of sound calculate किया, which was actually an incorrect value. Laplace made his correction to it, जहाँ पे उन्होंने बताया कि ये जो न्यूटन ने एक्चुअल में कैलकुलेट किया था this speed of sound, उन्होंने यहाँ पे एक काइंड ऑफ आइसोथर्मल कंप्रेशन को assume किया था, whereas the compression is actually adiabatic. And when I say compression, I simultaneously mean rarefaction, because compression and rarefaction, these two kind of regions are formed with wavelengths assigned to them in pressure and density changes, जिससे हमारी sound propagate करती है. And there Feynman derived the speed of sound according to Laplace method. And Feynman ने यहाँ पे speed of sound derive किया, which was derived to be something like 1 over the square root of 3 times the average speed of the molecules propagating around. What molecules? Air molecules. So you might say an RMS speed. Now the thing is, after Feynman derived it, Feynman told कि यहाँ पे since 1 over root 3 है, which is pretty much something like, what is root 3 की value? Well, it is something like 1.7. आपको clearly मिलता है कि जो RMS speed of molecules है, roughly इसी order की हमारी speed of sound भी होती है. So you have the RMS speed of air molecules. So in the same order of magnitude, you will have the speed of sound, or at least roughly in the same order of magnitude. Now the question is, why are they in the same order of magnitude? Well, the answer is clear. क्योंकि since speed of sound, since sound clearly air molecules के through propagate किया जा रहा है, air molecules sound को propagate कर रहे हैं, तो जो हमारी स्पीड ऑफ साउंड होनी चाहिए वो क्लियरली एयर मॉलिक्यूल्स के स्पीड के एटलीस्ट बराबर होनी चाहिए, और इफ नॉट बराबर होनी चाहिए, बट दीज आर ऑफ कोर्स द एयर मॉलिक्यूल्स दैट आर प्रोपगेटिंग इट, दे शुड बी इन द सेम ऑर्डर एटलीस्ट, क्योंकि इट कांट बी एनी फास्टर देन द आरएमएस स्पीड ऑफ मॉलिक्यूल्स. व्हाई? साउंड विल प्रोपगेट फास्टर देन द मॉलिक्यूल्स themselves, which is of course not possible since the molecules themselves are the ones propagating it. and it can't be any slower, or it could be something like this molecule goes over to this place and you have sound propagating from backward, and that just can't be possible. तो यहाँ पे फाइनमैन ने पहले डिराइव किया इस चीज को यूजिंग लाप्लास मेथड, एंड देन ही रीजन कि ऐसा ही होना चाहिए, ऐसा ही होना चाहिए, और इट वुडंट बी ऑफ कोर्स पॉसिबल द अदर वे अराउंड. नाउ द थिंग इज कि अगर आप फिजिक्स को इस तरीके से अंडरस्टैंड करने की कोशिश करते हो, व्हेन यू अंडरस्टैंड समथिंग मैथमेटिकली एंड देन यू फाइंड द रीजंस बिहाइंड दैट, ऑफ कोर्स व्हेन वी कंसर्न आवरसेल्फ विद रिसर्च प्रॉब्लम्स, सो इट गेट्स कंफ्यूजिंग दिस मेथड. रादर हमें थॉट एक्सपेरिमेंट्स इमेजिन करने पड़ते हैं, एंड वी हैव टू think of principles the way Einstein did of his equivalence principle, imagining a man falling from a building. But when you get to that level, so you have developed quite an intuition. आपने कुछ intuition develop किया है, which will help you understand the thing. And I'm not saying do not think things qualitatively. Well, actually, intuition is my thing. I don't really get things so much as from mathematics as I get from my intuition. Intuition is my own thing. But without actually solving the mathematics for that, you cannot get your intuition right. तो अगर आपको उस चीज को अंडरस्टैंड करना है, you need to actually supplement intuition alongside with mathematics, and this intuition and the required mathematical tools will actually give you an insight into the physical model or the physical principle that you are trying to learn or trying to maybe research about. That is how you actually are supposed to do physics. अदरवाइज आपको लगेगा कि आप इस चीज को अंडरस्टैंड कर रहे हो, बट विदाउट एक्चुअली अंडरस्टैंडिंग द मैथमेटिक्स एंड अंडरस्टैंडिंग द थिंग्स quantitatively, you can't solve problems of it. And when you can't solve problems of something, I believe you may not have understood it very properly, and you might fall into trap of various other kind of pseudoscience going around. Like one particular to mention something that I found very, you see, weird and bizarre, and something that is not quite true is the law of attraction, for instance. अब law of attraction क्या कहता है? I heard about it, and what I found was कि law of attraction, it is a way to manifest your dreams and into reality. So it's something like this. मैं यहाँ पे एक चेयर पे बैठा हूँ, I close my eyes and I think of myself being a great physicist or being a Nobel laureate. एंड अगर मैं ऐसा सोचता हूँ एंड मैं बिलीव करता हूँ कि मैं एक नोबेल लॉरिएट बन पाऊंगा, मुझे नोबेल प्राइज मिलेगा, और आई कैन बी ए प्रोफेसर ऑफ फिजिक्स एट एनी रिस्पेक्टेड यूनिवर्सिटी और स्कूल. तो if I think that way, I can manifest this particular thing in my life. And how does that happen? How can we actually do something just by thinking, just by the power of thinking alone? Well, what law of attraction tells you, that like attracts like, or at least that's what the law of attraction believers tell you. So what in one particular video I saw, so someone was explaining the law of attraction, and I found that they were explaining it such a way that in quantum physics, like attracts like. And see here, they don't understand quantum mechanics. Well, clearly no one does, but they don't even have an idea of what quantum mechanics tells you. So they tell you that in quantum physics, like attracts like. और इसीलिए जब आप खुद से पॉजिटिव एनर्जी रेडिएट करते हो एंड आप पॉजिटिव वाइब्रेशन या फिर पॉजिटिव फ्रीक्वेंसी से सोचते हो, तो यूनिवर्स की पॉजिटिव फ्रीक्वेंसी आपके साथ रेजोनेट करती है, और यूनिवर्स की पॉजिटिव वाइब्रेशन और फ्रीक्वेंसी आपकी पॉजिटिव वाइब्रेशन या फ्रीक्वेंसी को रिस्पॉन्ड करती है. एंड तो जब आप सोचोगे कि यू आर बिकमिंग अ नोबेल लॉरिएट, अ वेरी पॉजिटिव एनर्जी इंडीड, तब इस यूनिवर्स आपको हियर करेगा and it will make you a Nobel laureate, and sometime in future you are going to win a Nobel Prize. Well, it doesn't happen that way. Why doesn't it happen that way? Because like does not attract like. Because if you want to tell me like attracts like, just tell me like what. The question is like what? Like mass, like charge. Well, like mass seems to attract like mass. Like charge, no, it doesn't. So believers of the law of attraction might say, well, like energy. So can you tell me that how energy attracts other energy? Well, it is something like this. You have certain bodies, you have matter, and just with their sheer existence, they have certain amount of energy. So you have here a body, here a body. Masses हैं, obviously attract करती है. Newton told us, Einstein told us. Einstein ने भी बताया कि masses की वजह से हमारी energy होती है. So you might say that this is one example. Gravitation is one example of, you see, energy attracting energy. But the thing is, this energy, what is this energy that is attracting other? Well, this is the mass energy. And when you think of manifesting your dreams in real life, when you think of becoming a Nobel laureate, there isn't actually a mass energy involved. There is no mass energy involved. What energy is this? This is merely your thoughts. This is your consciousness, which is not the same thing as like attracting like. तो if you tell to me that quantum mechanics tells you that like attracts like और इसीलिए पॉजिटिव सोचने से आपके साथ पॉजिटिव चीजें होंगी, then it is not fact. Law of attraction is actually, what do I even call it? So law of attraction is not true. And why would you fall under the trap of law of attraction? Well, because you don't understand quantum mechanics well. And how do you understand or at least comprehend quantum mechanics well? By actually learning it rather than just hearing someone say that like attracts like, and you think, yeah, you learned a new concept of quantum mechanics today. Well, no, you didn't. Plus, this particular law of attraction, I find this particularly, you see, hateful even, because this promotes the idea of something like victim blaming. You find it is something like this. अगर आपके साथ कोई नेगेटिव चीज होती है, so what does that tell you? That tells you कि आपने कुछ नेगेटिव सोचा है, इसलिए आपके साथ नेगेटिव चीज हुई. So if COVID comes around, who would have thought, who would have wanted COVID to be there? मतलब अगर COVID-19 का पैंडेमिक आता है, does this mean कि किसी ने, और रादर ये पूरी दुनिया में स्प्रेड था, तो डज इट मीन कि पूरी दुनिया के सारे लोग इतने पेसिमिस्टिक थे that they thought or at least they manifested this COVID-19 into a real life? Well, no, they didn't. There are quite the optimistic people going around in this world. What does that tell you? Law of attraction doesn't work. It clearly doesn't work. It is a nice philosophical thought, of course, but relating it to quantum mechanics, no, it's bizarre. Because I wouldn't even regard it as a philosophy. It might be a way of life for you or something. You might want to actually use this thought that we should think positive things. इसके psychological effects definitely आते हैं, but it doesn't directly show up in your life. It doesn't show up in your life. It does have psychological effects, because when you think positive, you act positive, and now that is something I believe in. You think positive, you act positive, you work hard, you have a passion, and you find something. तो ऐसे नोबेल प्राइज जीतना पॉसिबल है. थिंक पॉजिटिव, you win the Nobel Prize through this indirect measure. But you merely think positive, you cannot say that like attracts like, and that is, and due to this law of quantum mechanics I won the Nobel Prize. No, you might have discovered some law of quantum mechanics that attracted you the Nobel Prize maybe. So there are quite these kind of, you see, peculiarities that are running around that are not really true, and you might believe in them. Why? Because you don't understand quantum mechanics while you think you do. You actually don't. And to understand this thing, you have to actually understand the mathematics behind it. और जब आप इसके पीछे की mathematics समझोगे, इसके पीछे की mathematics पढ़ोगे, and then you can actually make sense of Heisenberg's uncertainty principle. For instance, because you might think that you are able to comprehend the Heisenberg's uncertainty principle. Let me tell you, if you haven't studied about the Schrodinger equation and the wave function and the wave particle duality in detail in a physics textbook, in a quantum mechanics textbook, let me tell you, you don't understand Heisenberg's uncertainty principle. It is not what you think it is. कि अगर मैंने यहाँ पे एक पार्टिकल को रखा, आई हैव पोजीशन मोमेंटम, दोनों की वैल्यूज एक्यूरेटली मेजर नहीं कर सकते हैं. व्हाई? वेल, इसलिए नहीं मेजर कर सकते हैं, मे बी इनकी साइमल्टेनियस रियलिटीज नहीं हो सकती हैं. द वेरी सेम थिंग दैट आइंस्टाइन क्वेश्चन हिमसेल्फ इंडीड, बट ही वाज ऑन अ कंप्लीटली डिफरेंट पॉइंट. That time he was thinking a completely different thing, but the sentences might resonate quite a bit. So the thing is, you might think कि एक value of position and एक value of momentum साथ में calculate नहीं किया जा सकता. Well, it doesn't indeed tell you about one value of position or momentum. It tells you about their standard deviations that is meant by this uncertainty in position and momentum. तो अगर आप इसे चीज को not mathematically समझते हो, but आपने इसकी definition पढ़ा है, you don't understand Heisenberg's uncertainty principle. You need to look at the mathematical equation. I think I might even, yeah, here it is written. This is the uncertainty in position and the uncertainty in momentum. तो यहाँ पे इनकी standard deviations की बात होती है, because we know that the particle might be in superposition state of superposition. So it is the standard deviation that we talk about when we refer to the uncertainty in position and momentum. If you didn't read the equation, if you didn't understand actually the equation or the mathematics behind it, if you don't know what the standard deviations are, so if you don't know this concept of standard deviation, well, you don't understand the uncertainty principle, or you can't comprehend the idea of Heisenberg's uncertainty principle, for me to honestly tell you. So studying mathematics is important. It's not wrong to be watching popular science videos or something. I myself do. I myself watch the videos of some videos and clips of some really nice science popularizers to say. But the thing is to actually understand and comprehend the idea of or ideas of quantum mechanics or relativity or any physical model, आपको उस चीज की मैथमेटिक्स को समझना पड़ता है, उसे अंडरस्टैंड करना पड़ता है, and then only you can gain an actual physical insight into that model. That was all actually I wanted to say in this video, since as I myself saw there are so many science popularizers and they might tell you the right thing, but you gain the wrong idea without understanding the mathematics. So I thought it is quite necessary to tell as many people as I can, and it is also quite necessary for others to tell you all the very same thing, that things cannot be really comprehended or understood without the proper use of mathematics. That was all for today's video of mine, and thanks to all viewers.